Welcome back, everyone, to I&E's CCIE Data Center Nexus switching class. We're going to talk now about port security. So taking a look at port security, the idea is that we want to have a MAC address to port mapping. We basically want to ensure that the traffic that's coming in on any given port in our network is specifically from the MAC addresses that should be on that particular port. So really we don't want to allow traffic to pass other than from traffic or trusted sources that we know should be on that port based on their MAC address. So this can be done in either a static type mapping, where we actually define statically the MAC address for that port and we define it on the port. This is probably the exception to the case, not normally what we do. Most of the time what we do is a dynamic learning. So we basically learn the MAC address from the port, really the first MAC address or first set of MAC addresses, because we can have more than one if we define the maximum number, and we can actually define different maximum numbers for VLANs on things like trunked ports. But we can dynamically learn the MAC, map that to the port, and then we don't allow anyone else to send traffic from any other source that doesn't have that particular MAC address as their source MAC address in that outer Ethernet header. And then there's also the ability to age this dynamic mapping out. So we can say that the dynamic mapping, we learn, let's say, one MAC address from this port, or maybe even 5 or 10, whatever we define our maximum to be, because we know what type of devices are going to be behind this. And then we don't allow, and this is going to differ for every type of port. If it's a server, a non-virtualized server, then we will probably have one MAC address. We may make it static. We may make it dynamic. And but then again, we get into situations where these servers are moving, as we've talked about in the data center, moving from one workload to another. That's typically in a more virtualized environment. But we may have multiple MAC addresses coming in from something like another switch port, a trunk over a switch port. We might have them coming in from a 802.11 wireless access point. There's all sorts of different considerations as we turn on, or really think out our security policy and turn on port security and MAC to port mapping. But we can have these dynamic mappings age out. Also, we have the ability to do what's called a sticky mapping. So this is the same as a dynamic mapping, but instead we store the information in NVRAM, so that if we dynamically learn a MAC address and then the switch shuts down for any reason and it comes back up, it doesn't necessarily have to learn that MAC address again. It can be kept in NVRAM, loaded back into the switch's memory, and used to continue enforcing security there. Now, also taking a look at the violations. So what happens if we actually have a violation? Someone sends an Ethernet frame in and the source MAC address does not match what we have already dynamically learned or statically assigned for that port, then we can choose what to do. The violation action of shutdown is simple. It shuts down the port, and that's done. We also have the ability to restrict. And if we restrict, we're not shutting the port down, so we're allowing the traffic that was coming in from a valid source to continue to flow, but we're dropping all traffic from any other MAC addresses. And then we also have the ability to protect. Now, the idea is that it basically does the same thing as restrict. It basically drops the traffic from any other MAC addresses, source MAC addresses, like restrict. But first it learns the MAC address, and this is a key point. It only learns the MAC address of the first violator, and it logs him. It still drops his or her traffic as well, but it doesn't learn any other violators' MAC addresses. It learns that first violator's MAC address, and it logs them. Now, this is very important for our accounting in our ICE server. We want to know who is violating our security mechanisms. If we just do restrict, first of all, if we shut down, we not only shut down this is really the most extreme form, we not only shut down the violator, but we also shut down possible valid trusted sources. If we restrict traffic from from the invalid, the violator sources, and that's good, but we don't log it. But protect, really being the best of these options, we not only drop traffic from anyone that's violating, but we also log them so that we can go back and have a historical record. And we can configure, whoops, that doesn't look right. So we can configure port security on layer 2 interfaces only. And details about the different types of interfaces or ports are as follows. So access ports, we can configure port security on interfaces that we have configured as layer 2 access. That should probably go without saying, but we'll say it anyhow. On an access port, the port security applies only to that access VLAN. If we have a trunk port, then we can configure port security for the different VLANs that are traversing, and the device allows VLAN maximums only for the particular VLANs that are allowed on that trunk port. And we can also configure port security on span ports, but only the span source ports, not destination. That probably makes sense because our span destinations are really our packet capture devices, but our source ports, we're probably wanting the traffic to get through as well as be able to analyze it. So taking a look at some of the different port types, we have Ether port channels we can configure port security on as well in either access or trunked mode. Virtual port channels, so our VPC, we can configure port security on orphan ports, switch virtual ports, straight through PVCs, active-active VPCs, as well as enhanced VPCs, active-active being that back-to-back. And we can even do it on FEX ports, so the fabric extender as well as the GEM modules, those expansion module ports in a fabric extender. We can also configure port security for private VLAN ports.